Dear friends, welcome back to Data Analytics Talks. In this session, we are going to focus on data warehouses and the relevance of the data warehouses and when to choose the data warehouse. We will also try to understand the role of data engineer in building data warehouse. We will also have a high-level understanding of the various concepts like OLTP, OLAP, Operational Data Store, ETL, Azure Data Pipeline, ADF, and so on. This is my second video in the Azure Data Engineer Associate Learning Series playlist. I would not only request you to subscribe to this playlist, but also request you to share your feedback as comments. From an exam point of view, this video may not be that relevant, but from an understanding point of view, you will get to know what is a data warehouse and when to need a data warehouse. So let's start. Data is growing at a faster rate than ever before. 90% of the world data was created in the last 2 years. And every 2 years, the volume of data across the world doubles in size. Since our topic is data warehouse, let me start with a question. To manage your data, do you need a data warehouse in your company? To manage your data, do you need a data warehouse in your company? Some of you will say yes, some will say no. But to understand it, we need to look at how and why we use data in any organization. In other words, to know the purpose of the data, you should know the purpose of the data. So mainly the purpose of the data in any organization is twofold. First and foremost, it is an operational purpose. So rolling the daily activities. So it's the operational purpose. Second one is analytical decision making. We want to make data for better decision for the future and understand our organization better. So let's look in what is data warehouse and what is the data engineer's role in it. So a data warehouse centralizes and consolidates large amount of data from multiple sources. So we will see what is multiple sources later. And they are analytical data store based on OLAP systems. And you know what is OLAP? It's online analytical processing. We will see that in detail later. Look at a data warehouse engineer who is keen on looking at the data warehouse, right? A data warehouse engineer primarily role is to design and build data warehouses. And sometimes it differs company to company. Working at a smaller companies often means taking on many data related tasks in a generalist role. In larger companies, some data engineers are dedicated for building data pipelines and maintaining data warehouses. But again, it depends on company to company. And within the data engineer role, there could be beginners, intermediate, and experts. So with these multiple roles and expert category in mind, we have to build a clear understanding of what is data warehouse, why it is necessary, and when to go for it and when not to go for it, right? So in this video, I'm going to take up a business use case and elaborate these questions. I will introduce you to Case Steel plant and its IT landscape and the way how the increasing demand for informed decisions and predictive analytics based on the historical data. So the Case Steel is founded in 2012 and after a few years it made presence in other cities. Slowly in 2017 it's more presence in other states of the country. Then added multiple plants in different parts of the country. Then in 2019 it started exporting and it got ISO certified after 8 years of its foundation. Then recently celebrated its 10th anniversary. I just wanted to show the timeline to show the growth of the company and the way how the data has been generating in the company. In the last 13 years, the Case Steel has become a multi-billion multinational company and made many milestones. And coming to its operational aspects, Case Steel has many departments that work together in rolling the company. So it has an HR division, which is managing the human resource. It has a procurement division, which is managing its payments, purchases of raw materials, fuels, utilities, and other materials. It has a production unit which has the rolling mill and furnace. There is a marketing division which takes care of all the marketing needs. It has a QA division, that is a quality assurance division, which is maintaining the quality of the product. Again, a strong sales team which is researching and identifying potential customers, contacting them through various channels, and finally, they have a strong C-level executives, including chairman, board of directors, board of committee, and senior management. And each division is linked to IT. SAP module is supporting the HR, Salesforce is supporting the customer relation, and there are multiple custom applications which supports production, marketing, QA, and sales. And some of the reporting tools are being used for the executive levels. Here you can see how strongly each division and their IT department is linked. And there is an existing mechanism which is called ODS. What is ODS? It is an operational data store. So what is an ODS? It's a very important thing to know. An operational data store is a central database that provides a snapshot of the latest data from multiple transactional systems for operational reporting. It enables organization to combine data in its original format from various sources into a single destination to make it available for business reporting. Okay, what's the purpose? It is to make the data available for reporting purpose, but it stores in its original format without changing anything. And it is structured data. It is a normalized data. Okay. So I hope you understood the IT landscape of this case study, how data is generated. A company with multiple operational divisions generate huge transaction data on daily, weekly, monthly, and yearly basis. And you can see data grows like anything. So there are a lot of untapped data sitting in the databases. So the question is, what can we do with this data other than supporting operations and transactions? We have almost 13 years of data in our store. And can we use this data for something? There opens the world of data analytics for Kestil. It's a move from transactional space to analytical space. So now we want to pick up data analysis. So data analysis is the process of inspecting, cleansing, transforming, and modeling data with the goal of discovering useful information, informing conclusion, and supporting decision making. So having understood the power of data and to the extent data can provide insight, the Board of Governance asked every division to take advantage of the historical data to derive insight to bring efficiency, innovation, and be able to take informed decisions. So things are fast moving from transactional space to analytical space. So in response to the management call, a demand for insight based on historical data from all departments have increased immensely. So the executive committee wanted to review the changes in the customer sentiments. They want to see the financial performance over a period of time. They want to evaluate talent performance and employee behavior. They want to see the sales trends and potential markets, production-related challenges and quality breaches and actions taken. The IT team started looking into options to meet the executive's demand to tap historical data to arrive insight and help inform decisions. It's all about identifying the trends of the customer, the trends of the financial growth, the trends of the market, the trends of sale, the trends of the quality, all based on the historical data. So obviously the question is, as I was telling, like the IT department is thinking about options, right? So they ask, can we use the same relational database for analytical purpose? Every data engineer will ask, can we use the same relational database for analytical purpose? Does our operational data store, that is ODS, serve this purpose? So do we need to build something different than the transactional database? This is the question that every data engineer will ask yourself before building an analytical store. Yes, the question will have answers, yes or no. So in our case, the answer is no, because It's an operational data and it is designed as an OLTP system. What is OLTP? Is online transaction processing. It is optimized for transactions and not for heavy analytical processing. OLTP systems are optimized for transaction and not for heavy analytical processing. An operational database management system is software that is designed to allow users to easily define, modify, retrieve, and manage data in real time. Just note this point. Okay? And if the operational data store is not suitable, what is the alternative? Yes, we need to build an analytical data store, which is OLAP, Online Analytical Processing Systems. What does these systems do? It is optimized for heavy analytical processing. An analytical database or specialized database optimized for analytics. For example, through data storage, basically column-based, they're using hardware usage like in-memory, integrated functions like mining, architecture concepts and delivery terms like appliances. So their main benefits are faster query performance, better maintenance and scalability. Okay, now every engineer should make a comparison of what is there in OLTP, what is there in OLAP, what is in online transaction processing, what is in online analytical processing. You can compare these with different characteristics like query type. OLTP supports simple standard queries, but OLAP supports complex queries. Operations like based on insert, update, delete commands, but based on select command to aggregate data reporting. Then response time for OLTP it is milliseconds, OLAP it is seconds, minutes or hours depending on the amount of data to process. And you can see the sources are transactions, but OLAP sources are aggregated data from transactions. And you have the space, generally small historical data is archived, but whereas the OLAP, it is generally large due aggregating large data set. Then we have the database design will be normalized database for efficiency, but whereas OLAP it is a denormalized database for analysis. So you can spend some time analyzing OLTP, OLAP so that you get a right understanding about the transactional database and analytical database. So going for a data warehouse, hope you understand what is a data warehouse, right? It's OLAP systems designed for analytical purposes are called data warehouses. Like every other technology, the data warehouse patterns also keep evolving. So you can see legacy data warehouse patterns and modern data warehouse patterns. So sometimes they call us EDW, Enterprise Data Warehouses, and Modern Cloud Data Warehouses, MDW, EDW and MDW. So SQL Data Warehouse, Oracle Data Warehouse are examples of on-premises. They mainly support structured data, whereas modern data warehouses are cloud-based. They integrate all our data, including big data, with our data warehouse for analytical and reporting. All data formats are supported in modern data warehouse tools. We will look into that in very detail later in the coming sessions. So it is also good to understand some of the facilities that each data warehouse provides you. It provides you centralized and consistent location for data, better query performance, then gives you user-friendly, easy to understand interfaces, load data consistently and repeatedly using ETL tools, and there is a reporting and data visualization built on the top of it, and better data quality, faster business insight, smarter decision making, gaining and growing competitive advantage. You can read a lot about the advantages of data warehouses. It's also good to know how the data warehouse architecture look like. You can found single tier architecture, two tier architecture, and three tier architecture. And three-tier data warehouse architecture is the most widely used architecture of data warehouse. It consists of a top, middle, and bottom tier. And the bottom tier is the database, and middle tier OLAP server, which is implementing using either a OLAP or OLAP module. The top tier is always front-end client layer. So it's good to know how the architecture of the data warehouse works. Also, you should have a fair idea of the data warehouse components. There are 4 components of data warehouses: load manager, warehouse manager, query manager, and end user access tools. So as you learn more, I think these things gets more clearer to you. As you and me were expecting about the decision of the IT team about the data warehouse, they have decided to go for modern data warehouse. You know why? As I said, modern data warehouse support all types of data. However, the legacy data warehouse pattern supports only the structured data. Again, now this kind of steel plant produces not only the structured data, it produces a lot of unstructured and semi-structured data. All has to be accommodated in our data warehouse. So they will be going for a modern data warehouse, that too in Azure. Yes, it is a great opportunity for us also to learn various building blocks of Azure data warehouse, including the data sources, the process of ingest and preparation using Azure Data Factory, Azure Databricks, then the Azure Data Lake Storage, and you will also see how to model and serve using Azure Synapse Analytics. And finally, we will also consume the data using Power BI. So this is the right opportunity for us to learn Azure Data Warehouse, which is a modern data warehouse which is in cloud. So as a data engineer, what's our role? A data engineer will have to create a centralized analytical data store, OLAP. You will consume all the data sources like HR system, customer service, quality assurance, production automation, and C-level executive data, and we will use a data pipeline. Either use the ODS or we can skip ODS and use an ETL process, and we will bring the data into an analytical data store like Azure Synapse Analytics and share the data, expose the data to some visualization tool, either Tableau or Power BI, whatever they decide. So let's get prepared for the implementation. So hope you are able to understand the need of moving into analytical data store from transactional database. In the upcoming sessions, we will look into. So before closing, you should check your knowledge. So what are the 2 main purposes of processing data in a company? What is the main purpose of operational data? What is the main purpose of analytical data? What is the source of analytical data? What are the key characteristics of data warehouses? Who is creating data warehouse? Modern data warehouses are cloud-based, yes or no? Difference between OLAP and OLTP systems. 3-tier architecture is commonly used data warehouse architecture. Do you agree? What are the components of data warehouses? Please check your knowledge. If you have any doubts, come back to me. Thank you very much for watching this video. I hope Data Analytics Talks is really helping you to grow. If it is, please don't forget to share your comments in the comment box. Feel free to reach out to me. You can use the same comment box for the same. Thank you.